Hey there, boys and girls. Welcome to your Edpuzzle homework tonight, dealing with explaining lesson 9.8. So, again, we're going to go into that workbook and we're going to explain those pages that you're supposed to be working on as we're going through. So, if you have not done so already, please turn to page 340 and 341 and make sure as we're going through this, you're filling in the things you need to be filling in. All right, so just to make it a little bit easier to see, at the top of page 340, talking about lesson 9.8, what they're having you do is they're still having you compare fractions, but they're having you think about different ways that you can do it. So in our step in up here, it says, look at these two fractions. So I have 2/3 and I have 4/5. Okay, and it's asking you, what strategy would you use to decide which is greater or which is bigger? Okay, well, our little bird here is saying that she would compare them to the benchmark one whole, which means she's going to think about how close they are to one whole. Okay, something we've talked a lot about and what Chloe is thinking here is we want to find a common denominator. We want to find something that these two bottom numbers, 3 for thirds and 5 for fifths, we want to find something that they have in common. Okay, so they're asking you to complete the diagram here. So I've kind of zoomed in on these fractions here. Something we talked about is we could list all the multiples out for 3 and all the multiples out for 5, and then we could figure out what they have in common. And if I do that, I'm going to figure out the first thing I see that is the same is 15. And the reason why I have to do something like this is because they're not related. Okay, remember in an earlier video, we talked about how you might be able to get away with just changing one to match the other one, but that's not going to work. So that's why we have to come up with a common multiple. So we listed out all of our multiples here and figured out what was the same. Or, like we talked about just a day or two ago, you can multiply those denominators together. And if you do that, you're going to figure out a common multiple for both of them because these really just turn into factors then. So if I do 3 times 5, my new denominator is going to be 15, and it's going to be the same for both fractions. So now what we have to do is we just have to figure out what our new numerator is going to be. So if I'm filling in my diagram here as I go, so you should be doing this too, I notice that I did 3 times 5 on the bottom for this first fraction because all I did was multiply it with the other denominator. And if I did 3 times 5 on the bottom, that means I'm also going to multiply by 5 on the top. So if I do that, that means my new numerator is going to be, well, what's 2 times 5? Yeah, my new numerator here is going to be a 10. Let me just shrink that down a little bit there for you. So this fraction says 10/15. They're equivalent fractions because they take up the same amount of space. Now I've got to practice changing that other fraction though too. So let's think about what did we do on the bottom? Yep, we multiplied by the other denominator, which was a 3. So that means this is going to say times 3 on the bottom. Whoops. Times 3 on the bottom. And then, like we said, whatever you do to the bottom, you're going to also do to the top. So I'm going to multiply by 3 there as well. And then I just have to figure out what my new numerator is going to be. Well, 4 times 3 would get me, 4 times 3 is going to get me 12. So my new numerator over here is going to be a 12. And again, like we've talked about for the past few weeks, the reason why we do that is because now these are easier to compare. I know that 12/15 is bigger than 10/15, and the reason why I know that is because the denominators are the same, so the pieces are all the same size. And I know that 12 is more than 10. Nice job. Now, if you look down on that page a little bit, it also talks about how you could find a common numerator. So what we did on the last slide was we found a common denominator. We found a number on the bottom that could be the same, but you can also find a number on the top that could be the same. And the reason why they chose to do that is because, think about it, we really didn't have to change both of our numerators, did we? No, we were able to get one of them to match the other one by doing 2 times 2. That made the numerator on this first fraction now a 4, didn't it? And now you can see how those two fractions have the same numerator. So that tells us if you have the same numerator, that tells us we have the same number of pieces colored in. Remember, whatever we do to the bottom, whatever we do to the top, we also have to do the same thing on the bottom. So that's why we multiplied by 2 down here. So now my equivalent fraction here is 4/6, and I'm comparing that to the fraction I didn't have to change, which says 4/5. Okay, and like we've talked about, and you can kind of see that with my pizza example here, remember, the bigger that denominator, the more cuts you have to make on your model or on your pizza, and that means the smaller your pieces are going to get. So because this denominator is bigger, I'm going to have less space with these 4 pieces because those pieces have to be smaller. And we can kind of see that here. One of these pieces is definitely smaller than the other piece in this other model, isn't it? Yeah, very good. So that was another thing you could have thought of as well. Okay, and if we look down to the last part on page 340, yep, 340. All right, it's asking you that step up there, it's asking you to write your greater than or less than to make the statements true, and then they want you to explain how you did that. Well, for A, notice the denominators aren't the same and the numerators aren't the same, and really they're not that related in the sense where I could only change one. So A might be one of those problems where you want to find a common denominator. So you could list all your multiples out for 7 and all your multiples out for 9 and figure out what's the same. Or you could multiply them together and figure out that would be, that'd be 63. So then you just have to make sure you're doing the same things to your tops as well, and then figure out which one's bigger. Okay, I'm not worried about you solving these. This is kind of walking you through what you could do here. Okay, and then B, this is where your understanding of fractions could be really good, because you notice when you see 4/6, you know 4/6 is more than half, because half of 6 would be, 3. And if you've got 4 pieces, you know you have more than half. When you look at your other fraction over here, this says 3/8. Well, 3/8 is not more than half because, 3 is less than 4 and 4 is half of 8. So you know that this one would be bigger because it's more than half, and this one is less than half. So again, those are some of those strategies that you could also think about instead of trying to get your bottom numbers or your top numbers to be the same. All right, so the work you've got left to do today in your books is you've got to do problem 2, letters A through F. So you've got to do those 6 problems. Now, what I would like you to do for most of these is I would like you to continue practicing finding a common denominator. Okay, so finding how to get those bottom numbers to be the same. All right, so for example, I'm just going to do one here with you. If I was going to do E, if I look at my denominators of 5 and 2, I know those aren't the same, I know they're not related, but I can multiply those together so that I come up with a common denominator. And I know that 5 times 2 is going to get me 10. So I know those fractions now are going to have 10s on the bottom. And now whatever I did to the bottom, I also have to do the top. So here I would have done 2 times 5. So that means I also have to multiply my numerator by 5. And then on the other side, I did 5 times 2. So I also have to multiply my numerator on this side by 2. And notice how all we're doing there is we're just doing the same thing to the top that we also did to the bottom to get it to change. Well, 2 times 6 is, 2 times 6 is 12. So I have 12 tenths here. And then 3 times 5 is, 15. And now again, these are easier to compare because the denominators are the same. Which is more, 12 tenths or 15 tenths? Yeah, very good. 15 tenths is bigger, so that means 3/2 up above is also going to be bigger. Okay, so I want you to practice solving the rest of those. We'll go over those later on. Have a good night. Make smart choices.